Hello, everybody. My name is Nikolay Volf. I'm CEO and founder of Gear.exe. Um, and in our company, we really try to provide the best development experience in the Web3 world. By doing that, we launched our standalone chain last year, which is Wire Network. And since it really has some great uses, but it's kind of standalone and lacks some use cases for general, so to speak, audience. And so this year we launched what is called Gear.exe. And this is basically the same wire network, just for Ethereum, where it can really compose with Ethereum itself, but otherwise being this same application platform that we are working like for years already. Okay. Any application platform is actually a computational platform along with storage platform and so on. But if we kind of think about what would be the optimal way of doing computations in Web3 world, given that we still stick to those Web3 values like decentralization, trustless, and so on, and also the ability to run on typical user hardware instead of like some giant supercomputers, which is also kind of linked to decentralization a lot. And if we kind of see the current situation on Ethereum, for example, like excluding rollups, for example, we could take like Ethereum as a single computer. Then obviously, like it's and many other blockchain systems also lack of this. So everybody basically verify everything. In Ethereum also there is like a monolithic security where every little operation get secured by a very large amount of stake. This, for example, if I send like $1 to my buddy, then it's still like the whole machine of Ethereum security kind of will verify and execute this operation despite of it that is just $1. But what would be the optimal way to do exactly this, for example? And I would argue that, for example, if I just spawn my own web server on my laptop and let it run to serve user requests, then that could be indeed optimal. It just executes one operation, it executes what it needs. It's also contain his own data on its like a hard disk or whatever, and the this web server will also kind of have all the security mechanism, all the security assumptions about what it can do or what it cannot do because it's kind of self-contained. And then, but obviously this solution wouldn't be trusted since we have no idea of why would web server will work this way or that way. It can kind of do whatever it wants, and we can't trust this. And so obviously, there is a solution that allows us to judge this web server that it does exactly what it wants, and those are zero knowledge proofs. And they are used for many different things, but one of the things is that basically they answer the question: if I run this instruction set on top of this input data, then I will get this output result, and basically I can have a cryptographic proof of that is correct. So web server plus these zero knowledge tricks can be indeed optimal. There are some other small considerations in terms of censorship resistant and so on, but still, if we augment our web server with these zero knowledge proofs, then this indeed can be optimal. It kind of has all we need to be a good application platform. And then but if we kind of try to look how zero knowledge proof generation work, we see that this kind of generation is far from optimal. So for example, for any single instructions, we get million more instructions that executes along the way. You have this very big computational inefficiency and it's bad for application platform, obviously. Also, it adds a lot of latency where you have your final kind of confirmation verify into the future. And it's obviously leads to poor user experience as well. And then also good about the zero knowledge proofs is that they can be recursive. So for example, I can include, if I have already some source of data that is already proven by some zero knowledge prover, then I kind of can include the verification of this proof inside my own proof. And so my final proof will kind of verify everything that happened before that along the way, along the whole execution path. So and so maybe like we have this particular value of verified execution. Maybe we can use something else to just substitute this little part that tells us the right results on particular computation results. And if we look to liquid staking, for example, mechanism which becomes popular in recent months. So what is liquid staking? What is liquid staking? What is liquid staking? It's when you kind of secure the network. For example, for Ethereum, it's like an Ether token with a Ether token. Then you kind of with regular staking, you just lock the token and you don't have access to it. But with liquid staking, then you kind of in return of what you stake, you get also this liquid tokens that you can use for whatever you want, and you always can back your original token one-to-one. And then when you also use this liquid token to stake for something else, for example, then you get this liquid restaking mechanism. And there are a lot of platforms that have that have this liquid restaking service. Basically, one of them being EigenLayer. The other one is Symbiotic. I like kind of Symbiotic approach best more because they are more general, also immutable, and has all the great stuff there. And so since we have basically a set of operators that can use very divisible stake that to secure different operations, we can basically ask them different questions about what is true about this world, and they basically can answer any question, including the questions about our, remember the example with the web server, including the question about whether this web server does the correct computations. And yeah, having said all that, let's get back to what we are doing. As I mentioned, we basically try to provide the best development experience in the world in the Web3, and we are doing it we are doing it by kind of interpreting each application as an individual small rollup that has all the self-contained state within it. And then the whole network of these rollups form a so-called rollup swarm. And each of the individual applications, I would say web servers or whatever, but they're kind of self-contained pieces of software, basic applications. And then they are able to receive any messages from each other and receive any messages from Ethereum in real time. And they work obviously in highly parallelizable manner, where each of them kind of can execute everything that happens on Ethereum, but also at the same time can accept transactions from outside the network, from end users basically, and then processes further by messaging other applications or going back to Ethereum and submitting results there. So this kind of can work by both serving Ethereum to improve its computations and then serving regular users for some very fast operations they might need directly. And then we have these operators which basically randomly assign it to some applications where, for example, like one third of operators, one fourth of operators serve this application at this particular kind of epoch of staking. Whereas once this epoch overs, they kind of randomly assign to different application, and so we get like unpredictable assignment of operators to applications, which just improves the security, but also it's in performance because, for example, when application one sends something to application two, this is just kind of can be communicated with on a network layer, and then once they send this message, they kind of start already working while the first group of operators start working on something else, and we get kind of parallelization not only on like a hardware level, but also on a large scale of networking layer. But this also gives us storage parallelism where not all operators / validators keep all the data they need to kind of handle all the operations, because obviously every application has its isolated storage and assumptions about what they will be executing, what they won't be executed, and kind of have their own ability to judge about user and so on. Funny thing that liquid restaking mechanism can also be used to kind of do this recursive proofs that zero knowledge do. So basically, in every validation of some statement, you can also verify another statement from a different set of operators, for example, and include the total check in your execution model and verification model. Yeah, and obviously the whole system is completely permissionless. It's secured by like a completely permissionless mechanism of symbiotic, where basically anybody can participate, anybody can spawn an operator, and good to go. We cannot kind of prohibit it or whatever. And all this works on a simple laptop, for example, or any typical cloud machine. And Gear.exe itself as a platform, it's obviously a modern application platform. It's programmable with Rust, and Rust is really kind of language to go. I mean, most of the blockchains are written in Rust, and it has very nice properties of being memory safe, being like safe in many other ways. Maybe a little bit hard to learn, but it has a lot of very high-level abstractions, which are great for financial applications where you can really model very complex models, and all of them in a type-safe manner. And then the platform itself has very kind of modern way of programming where you don't need to design storage, you don't need to design anything. Basically, you just like write a regular program. I mean, any regular program can also work unless it uses some, graphics or whatever. But obviously, one don't want to put that. But development experience is really isn't different of how would you like develop web 2 web services or whatever. And all this thing also has a AI level performance. So I would guess it's has like a 300 CPU cores under the hood, and it can really perform very fast. And also all these cores work in really native speeds, around native speed. And for those internal transactions that come to this network from outside of the world, it can process really fast. So you have a little time. So essentially, if we kind of think about Ethereum computer, Ethereum network as a world computer, as a CPU for this computer, we can think about what we are doing with Gear.exe as a GPU for this computer. Actually, we initially kind of named our project as a Ethereum GPU, but kind of there was a lot of confusions along the way, and we kind of decided to skip this name and do a more general one. So basically, we augment Ethereum network, which is kind of CPU with a proper GPU, which can handle tasks that original CPU was never designed to do, and has a massive improvement and parallelism to serve it. And Gear.exe obviously solves many problems that Ethereum mainnet has without leading to any fragmentation or error. So while, for example, many L2 solutions, unless they have like real-time zero-knowledge snarks, really struggle with liquidity fragmentation across all the L2s. And then while we kind of any program that works on Gear.exe has also Ethereum interface on the mainnet, so that it can be interacted as you interact with any other Ethereum smart contract. And obviously, as a being modern application platform, we kind of can use modern techniques like pre-confirmation, for example. And once Ethereum itself has pre-confirmation, we kind of can compose with those to make pre-confirmations work even smoother and more natively as on Ethereum itself. And we have a reverse gas model, so-called, where really user doesn't need to have any funds to interact with this in most cases, unless he kind of goes through Ethereum side. But all the gas costs are covered by application developers, and it's kind of their job to keep their applications, web servers running. Yeah, I thank you for listening. Hope it was useful. And I'm always around the venue, so you can give me a touch. Thank you.